Hello everyone. So today I am going to introduce you to a very useful labeling software. It is of course an open source software. You don't have to pay it for or anything like that. It is freely available. This is called as LabelImg. Now the question is why we are doing this labeling? In which kind of situation we need labeling? So let's say you have a computer vision based project and you are trying to develop a customized object detection and tracking machine learning model. What does it mean? For example, let's say you have this kind of a setup and you have some kind of markers located at different body point location like this, and you want a machine learning model to understand these labels as well as track them. So here I have my output. I will just play it and show you here. So my developed model, my trained customized object detection and tracing machine learning model is able to track each of these markers, which is called as 1, 2, 3, 4, 5, etc. in a very efficient way. Some points are missing. It is because of the problem in the accuracy. I didn't train it well. So here you can see to develop this kind of a setup, you want, first of all, you want a data set. And then you have to label these markers using some kind of annotation software, isn't it? Here, you will have this kind of a recording of the prototype setup or whatever. You will get those kind of videos. You can just record them. And you can even extract frames from this video. But then how you are going to actually say to your model that this is my marker number one and this star kind of marker, this is my marker number two, like that. How are you going to do that? So in this kind of situation is where you need a image annotation software. So that is where we have to use a annotation tool. So here, label image is a very useful one because it has a very nice user interface and it is very easy to use and make XML files. So here the annotations will be saved as XML files in that's in Pascal VOC format, which is the same format used by ImageNet dataset. So all you will have to do is to just get those XML files and then later you can use those XML files for your machine learning task, project or whatever. You can just load them to wherever location you want. So I will tell you in a step-by-step manner how you can download this one and then how you can use this particular software. I will give the link where you can download the files. So it is actually a folder called label image master, which I will give the description where you can download that particular folder. So after that, what you have to do is you have to go to your command prompt. Just open the command prompt. Just open it. Now I will have to tell you why we are going here to your command prompt. It is basically because this label image, this open source software, it is written in Python and you have to compile the Python code after downloading. Then only you can get the interface loaded into your system. So that is why we have to go to your command prompt. After going to your command prompt, change the directory to wherever you have downloaded the file. So I have just kept it in my download folder. So I am changing my directory to downloads. So just write cd downloads, then hit enter. Now your directory is changed to your downloads. Now again change the directory to label image master. So this label image master is the folder which we are downloading from their GitHub repository. I will give the link in the description. You don't have to worry about it. So after downloading it, just keep it in the downloads folder itself. After that, you have to change the directory to this particular folder, label image master. Click enter. Now you are in this particular directory. Now just write Python label image dot py. So this is the Python file that we are going to run. After running this, we will get our label image software open in our system. Just hit enter. Then wait for a few seconds. It will get loaded. Here it is. So this is the interface of the software. Now go to this open here in the top corner. You can see this open, or either you can, if you are going to annotate only one image, then you can use open. If you have a folder in which all the images which you are going to annotate are saved, then you can use this open directory. So here I am having a folder in which all my images which I extracted from the video clip I showed you before is there located. It is there. So I have to open this directory. So click on this open directory and go to wherever location you have your files, your data sets. Here I am having this particular folder. Just click on it and then select folder. Now here, your all images are getting loaded inside your software. Here you can see all the images inside my this folder. So let's say I am going to call this particular marker as 1 and this one 2, this one 3, this one 4, this one 5. So what I want here, I want my object detection and tracking machine learning model to understand this one as 1 and keep on tracking it wherever it is appearing in the video. Similarly, it should track here as 2, this one and this one as 3, like that. So we are trying to develop a customized object detection and tracking machine learning model. Now, how we are going to annotate this? First, right click here, somewhere here, then you will see this create rect box. Click on it. Either you can right click here or you can see here, there is one create rect box option here. You can do that also. Now, draw one rectangle like this and give the name. So I am calling it as 1. Just give OK. Similarly, give for other markers. Let's say mine is 2 here. You can do any kind of customized detection model. So you can train it to track any kind of markers or whatever you want in your video frames. Here I am having my file. Now what you have to do? After done with labeling all the labels in one particular image, click on this save option. Now what is going to happen? It is automatically getting saved as an XML file in the same folder. In here you can see this was the folder in which all my images were kept. So in the same folder I am getting my XML file saved. So let's save this as frame 0 itself. Okay, now that is done. It is saved. Now you can click here and go to next image and do the same kind of labeling. Once you are done with it, you can close your this one. But now let's see how this XML file will look. Let's go to our folder and see how it looks here. Let's open it and see how what is there inside this. Okay, here. So we are getting the annotation in the same Pascal VOC format which is used by the ImageNet dataset. Here you can see the width, height and depth of the entire frame and wherever the location, at which location our first one, the marker named as 1 is located. So it is the Xmin, Ymin and Xmax and Ymax of one particular marker that is getting stored here. Now I will tell you what is this Xmin, Ymin, Xmax and Ymax. Just to note here that for each of this marker you are getting these 4 values stored in this particular XML file. So for 1 you can see this here, for 2 you can similarly see this here, 3 also you can see, similarly 4 and 5. Now what is this 1, 2, 3, 4, 5? Okay, let's go back to our file and so go back to our previous image. So this particular top left corner, this particular rectangle, this getting highlighted here, this particular top left corner, the x location of this particular corner is getting saved as x min. Similarly, y location, y coordinate of this will be getting saved as y min. Similarly, this one, the bottom right corner, whatever the x and y coordinate of this particular corner is getting saved in x max and y max. So we are basically getting the x max and y max of this corner and x min and y min of this corner. Now, with respect to which origin this is getting computed. So, for every frame in label image, when you are doing the annotation, for every frame, for every image, this top left corner of your particular frame is taken as origin. So 0 is here. This is the x axis and this is taken as the y axis. So here this x will be computed with respect to this origin. Similarly y. So this will have a lower x value and lower y value as compared to this one because our x is in this direction and y is in bottom direction. X is in right direction, y is in bottom direction. So for all these, we will get the value same. Now, why this is useful? This is mainly because now this particular characterizes at which location we are having this particular marker in this particular frame. So if we are having x min, y min and x max, y max, you can simply compute using the x min plus y, x min plus x max by 2 will give you the center of x coordinate of the center location, the centroid. Similarly, y min plus y max by 2 will give you the the y coordinate of the centroid. So in that way, you will know at what particular location you are having this particular marker. Where is its center located with respect to this origin. Similarly, for all of these, for every frame, if you know where exactly the location is, you can use that data. You will have to annotate some 50 or 100 like that. Then after that, you can use that data to train your ML model. So you will have to train it using this 1, 2, 3, 4, 5 marker. We will see in another video how we can use this marker to train a particular new ML model to train this kind of a setup. So for now, just understand that this is how we can do the annotation. So for some images, you can continue this kind of work for few of these images and then you will get XML file saved in this particular folder. With all these frames, you will have one XML file. After that, you can just load this particular folder into Colab or Jupyter Notebook or wherever you are going to write your remaining course. So that's all. Thank you.